Hey everyone, uh, my name is Ganesh. I am a DevOps engineer or an SRE or a platform engineer. I'm always confused about those things. I'd like to call myself a platform engineer, but I also have all the other skills to be any other engineer. I feel personally, I keep them sharp. Anyways, so the point of this recording this video is to put my content out there. um, and that is very recently is most recently happened blogs. I write blogs from time to time about the things that I learn and how they can be used to make your life better. So the very recent blog that I wrote about is how can we use something very common, we all know about that, that is SSH keys, to make our connectivity to different VMs more secure and simpler, because we won't be needing to use anything else if we kept using SSH keys. Yeah, and not just that, you can also use SSH keys to connect to GitHub or Gitlab or any other more like a major source code platform. You can use SSH keys to get a communication over there. Um, and not only that, like how can you use this feature of authentication and authorization to GitHub from a remote machine without you actually needing to, copy files from your local machine to the remote VM, anything else. I'm going to showcase how you can do that. So let's begin. Uh, I'm gonna share the blog's link in my video whenever I put it out, but this is it. So as I talked about, let's begin with trying to understand what is an SSH key. I'm gonna go into a temporary directory and I'm gonna operate from there. So as I already told, SSH is like secure shell, is an acronym for secure shell, which is nothing but a protocol that lets you connect to a shell of a machine in a secure way. When I say secure, it means in an encrypted way. SSH keys are nothing but the keys which enable that encrypted connection. Uh, so uh, the what do you call it? The base layer of code or the library which enables this is mostly OpenSSH. If you do man SSH on your own machine, you will get a manual of what kind of SSH protocol is installed on your machine. It's most likely SSH, OpenSSH, and the command used to create an SSH key using OpenSSH is SSH-keygen. Now, when you do that, it will ask you where do you want this new key to be created. I'm not going to use the default home directory because it has my private files. I'm gonna just give it a temp name, which means that it will create that file in the current directory with the name of temp. Now it is asking me for a passphrase. Remember guys, whenever you are creating any key, encryption key, you need it password protected and the password should be very strong. You don't want any loose password for it. So I'm gonna type in my very secure password over here. That is it. It took some time and it created the key for me. It also printed out like a fingerprint of that key. Fingerprint is like the identifier for that key, and then a random art. I don't know what it means. If anyone knows, you can share about it with me. Uh, so if I do ls, that is list the files which it created, you can see that it created two files. One is the temp and then one is a temp pub. Let's list out the contents. Temp is basically the private key within like the SSH armor. These two lines are called like the SSH armor or GPG armor, whatever it is. And then the temp.pub is basically the public counterpart of this key. Now, if you don't know what a private counterpart and a public counterpart of a key pair is, go learn something from the cryptography books of yours. It's a complicated progress. It's a complicated topic, but the private key is something which you hold near and dear to yourself and you keep it protected. And the public key is something that you share with others. Now, what it does is when you are trying to communicate with someone, you basically encrypt and sign your message using your private key, and the person who is uh, like receiving your message, they try to identify whether this message was created by you by decrypting it with the public key, as well as with calculating the digest and verifying that the message indeed came from you. So that's all about it. Now when we did this command, it generated two files. Those are here. Now let's look at some interesting bits. I'm gonna first showcase to you how using the SSH keys you can connect to a VM. I'm gonna create a new VM, SSH demo template default, in limactl. If you don't know, while it is running, it's like a Cloud Native Foundation toolkit which enables you to create VMs very fast. If you just see, I just typed it out. I just typed this command out and a VM has already been created. I named it SSH demo and it was in a stopped state. Now using the limactl command again, I am starting it up. And if you looked at the command before, I created a VM using the default template, which uses nothing but the latest, release using Ubuntu images. I am within a VM and I'm going to showcase how you can enable connectivity from your side into that VM using that SSH key. So in every VM, like in every system that supports SSH and has SSH enabled, there is always a folder called .ssh in the user's home directory, which contains a file called authorized key. Right now it only has one key, which is generated by limactl itself. In this file, what I can do is copy our public key that we just created and enter that, and now the open SSH agent in that VM knows about our private key. So now if I go back to the other side, list the VM, copy the port at which the SSH agent on this VM is running, and try to go into that VM using the identity file that we just created. So, yeah, so you can see that I was able to log in to this machine using the identity file. So that's how you enable SSH into a VM using the SSH keys. Now the next step is connectivity to GitHub or GitLab. Now the thing that I want to talk about is connectivity to your Git and GitHub account using the SSH keys. So it is again simple and straightforward, just like we did with the VM. That is, the thing we do is go into our VM, copy the public part of our you know uh, key, go into our GitHub account, settings, SSH and GPG keys, new SSH key, paste that key in, give it uh, you know a name, and yeah. Now we can use the SSH protocol to check whether authentication with key works or not. So yes, you can see that the username on which I added this key is Dovoxo5942 5972, and I was able to authenticate using my private key with just that. Now authentication works. Let's try to clone a repository. As you can see, this Dovoxo 5972 test repo is like a private repository. So it is unavailable for me to clone this repository. Because yeah, it'll ask me for username and password, which I don't have, and the authentication will fail. But we can use the SSH protocol, that is git@github.com, and then colon the username of your user, as well as slash the repository name. Now we do that, and what it is going to do is use the SSH key now. Yeah. Stop this. Hey, so I ended up recording the thing without changing the scene. That is, I was recording my face and not my screen. So I will have to record again, and although that was a good thing, but I'm not here to just show my face. So, and I'm gonna go back again and try again. So now let's look at the keys which are available on our SSH agent right now. So when you do L, you showcase the signature. When you do like a capital L, you show the public counterpart of the key. So now if I just to verify that this is the same thing which is added to our agent, I can, print the public counterpart, and we can see that it is indeed the same thing. Test repo, yeah. So now we are in this. So it indeed used the credential, that is the SSH key, and cloned the repository. Now there is also this concept of code signing. That is, you can use your GitHub credentials to interact with the GitHub APIs. That is, push a commit, pull a commit, read a branch or anything. But there is another layer of security that you can add, that is you can sign your commits. So whatever change you create at the time of creation of that change, you can sign it with a cryptographic key, and tell GitHub about that cryptographic key. So what will happen is every time you interact with the GitHub APIs and send any changes, GitHub, you have already notified GitHub about that you own a cryptography key. So whenever you interact with it and you push a change, GitHub will try to verify that this change that you just pushed, it was pushed using correct credentials, but whether it is signed properly or not. So that adds another layer of protection. So we're going to see how we can do that. So in order to do that, you have to actually change the git settings, git configs. If I do git config L, you can see that it is already configured for me locally, and it is using my credentials. But I want to show you how you can do that. So I'm gonna do it again. Git config local, and then user dot name Ganesh Tiwari, and then this is basically me. Oh, sorry. Oh yeah, I should not do that. This is basically me trying to show you how to set up that configuration. So doxo user, and then email doxo 5972 @dosb.com, and then gpg.format. I'm gonna set, so this signing that happens on a code can be done using multiple ways. You can use different kinds of keys. Right now I'm going to show you SSH, so I will set the GPG format as SSH, and then I have to let the config know which actual file that I want to use to sign, which actually public key file I want to use to sign the commits. So you can specify that by using user.signing keys, temp dot ssh, and then temp. Once I do that, I can do get config list, and at the very bottom, do you see that? Yes, username, user email, user signing key, and then GPG format. Now if I vm new file 2.txt I created, this is a new file, git log git commit, sorry, yeah, I need to first add that file, and then you can see that when I create a commit, it is all by itself attaching a new line called signed off by, and it is adding my username as well as my user email to tell the commit message that it was signed by me and this email. So a new file. Now if I do again, yeah, so it is signed. If I do git push, you can see that it should list my, new file signed off by, and it is listing it as a verified commit. But the way that this is verified and this is unverified is because the public counterpart, like this is also signed, but this is signed by a key which was in my name. But the public counterpart, this user has not uploaded their public signing key. Yes, you can see. So what happens is, once you start signing your commit, you have to tell GitHub about the public counterpart of it. So just like we went here and we added an authentication key, you need to add signing key as well. So in our case, we are using the same authentication key as well as the signing key, just because this is a demo. But in an ideal case, you would use two different keys to do anything. Yeah. So that is that. Now, since we have this idea of how that can we use an SSH key to log into a VM, how do we use an SSH key to interact with GitHub, the next question comes around is, okay, so we are able to interact with GitHub on our machine. We are able to log into a VM, but once we are in a VM, how do we interact with GitHub within that VM? Yeah, so the next part is just doing that. Next part will answer that question. So if you do SSH add and then L, you can see that the agent which is running on my machine has this SSH key added to its agent. And if you see, this is like a VM, VM created by the Lima thing, an Ubuntu VM. And if I list the keys on this machine as of now, it is none. So what I can do is Lima CTL list and then copy this exact thing and then SSH, provide that identity file, IP address and port, and yeah, if we do that, we are in that VM again, and the VM has no identities, but in this command we can add a flag called -a, and once we do that, what that will do is, it will forward the same key that is available on my local machine to this VM as well. Now what this opens up is the possibility of me authenticating to GitHub using the same private key that was on my machine. So as you can see, this is like a VM. It does not have the private keys or the public keys that was on my machine, but it is able to authenticate as if it was me. So there's that. You can even clone a repository as if it was you. Toboxo 5972 /test repo, and basically you can do all the same things that you were able to do in your local machine. I want to showcase how you can create a signed commit. So that is different because in our case, the public key file was available on our machine, so we just pointed towards it. But here, if I do git config and then L, you can see that the config over here, let me clear this. You can see the config over here is very small. It does not have anything. So if I have to config local user.name dovok, so again 5792@gmail.com, and then gpg.format SSH, and then in place of the signing key, what would you specify? So you can do two things. You can either provide this whole thing as a raw string, or what you can do is go into your SSH directory in your VM, and there is no public file present. Just create a public file with the reference of my public file, create something, and within that file you enter the public counterpart, and when setting the config you provide the path to it. So that is home.ssh, and then my dash public dash file dot pub. Oh, sorry. Yeah. So if I go to test repo and then do the command again, yes. And if I do git config L now, you can see that my username, email, and my signing key is set up here. Vim new file to change made from my VM, git status, git add new file to git commit. This is a commit created by VM using my signing key. Oh yeah, this is like a different editor. So, and if I push this again, so you can see that this is the VM. It is pushing all of my changes, and it was able to push it. And I can click on this repo. You can see this is the commit was made. Oh yeah, the email setup was incorrect for some reasons. So git config L. Oh yeah, the email is set up to be .gmail.com. DOSB.com. Doxo 5972, sorry. 5972 @dosb.com. And then git rebase head sign off, sign, and then push with force. And then I reload this page again, and hopefully it should be signed. Yeah. So now you see it is created by my user and it is using the correct email and it is verified. So that was done. So using the SSH agent forwarding, you can log into a VM using the forwarded agent. You can clone a repo, commit as if you were, uh, and that solves that problem. Now, one important information that I would like to add to this is when you do agent forwarding, it is not usually considered like a safe option, because if you are SSHing into a machine which is like not your controlled by you or your org, since the forwarded thing is like a Unix socket, so basically which means that it is a file. Anyone with root privileges on that machine can interact with the socket and behave as if it was you. So, which means that the VM was already compromised and a very bigger issue has already happened. But still, that is a thing that you need to know before you start using this. So, I dug up on things and I found out that SSH by default, um, not by default, but like the official documentation of it supports official, like the schema of it supports a flag called -c. So when we did, SSH add to add a file, a private key to our SSH agent, you can provide like a -c, and then so let's go back. So now SSH add, remove all the identities, SSH add, and then use the -c flag, and then add the temp public key. And then what it does is it adds the private key to the agent, but every use of the key should be confirmed by the user. Which means is even though the key file is forwarded to your remote machine, that is, if you say this one, SSH add L, like the key is forwarded as of now, but git, like if I try to, I don't know if it'll work or not, git at the rate github.com. Yeah, you can see that it will fail now because the agent refused operation, and that is because we did add the key, but we added a C flag. That is, the user must confirm. That is, if the key was created on my root machine, I should confirm the use of that key on the remote machine. Now, this by default is not supported on Mac, and that is a very bad feature. I think Apple should do something about it. But in some operating systems, it is supported, and I am going to show you use case as such. Okay, so let's start again. Let me try to explain the situation right now. So what I am recording right now is like a Fedora XFCE virtual machine running on UTM, and in this VM, this is a live environment. I have created an SSH key, which is the ED 25519 key, as well as I have installed a tool which is known as labctl. Labctl is nothing but a tool to connect to Iximiuz Labs. Iximiuz Labs allows you to, create virtual machines on the fly to learn server-side things. So the reason why I do this is because I want to showcase you the usage of the SSH key on the Fedora virtual machine itself. And then I also want to showcase when I forward the key from the Fedora virtual machine to a labctl virtual machine, it behaves in the same way and it asks for the permission to use the key in both the cases. Okay, so let's look at the SSH agent on my local Fedora box and see that there is nothing uh, currently added to the agent. Now let's try to add the ID ED 25519. Now it is added. Also, this same you know key that we just added has also been added to GitHub. If you can see here, this one, temp Fedora host test. I've also added this. So what this means is this key should be able to authenticate to GitHub from this VM. So now let's try that. Yes, so you see, I added this key without the C flag, so it did not ask for me any permissions. Let's now remove the key and add it back again, but this time with the C flag. It has now been added, and let's try to test connection to GitHub again. You can see that it pops open a window and says that a key usage is required. As soon as I say yes, it works. Now let's try to use that again. Again, a window will be pop opened and it will say. So this is how the C flag affects the usage of the key. Unfortunately, this is not available on Mac. I would request Apple to add it. And then over here as well, if we do L, you can see that the same key is present over here. Let's try to, yeah, this is the labctl virtual machine that I was talking about. So from this Fedora virtual machine, I am SSH'd into a labctl virtual machine, and I feel like I am in an inception. So here you can see when I invoked the SSH connection command on the virtual machine, because the keyword was added to the agent using the -c flag over here, it is asking for the permission from me on the local machine before using it. Now let's try that again, and at this time deny the permission. So this time it won't work. So this is a way to control the behavior of the SSH agent. Like when you add a key to the SSH agent, you control it by giving the -c flag, and that would make it so that each time a key usage is required, someone needs to approve it. Right, so this is again a cut, and I want to finish the video by saying this. In this video, we started with learning how to create an SSH key. How do you authenticate with using an SSH key to a VM? How do you authenticate it using it with a GitHub or Gitlab? I think we only did GitHub. And then we learned how to forward that agent to a remote machine, and on that remote machine, how to use it to do all of the same things that we did on a local machine. And then we learned the use case of the -c flag and how Mac for some reason still does not support it. And then I showed you how it is supposed to work on a Fedora XFCE box. I did put some time and effort into this, and I feel like it has taken more time than it should have. Also, the video is going to be very long than it should be. But if you liked and you enjoyed the content, let me know in the comments how you feel about it. And if you want any improvements that I can do apart from, being slow, do let me know. That's it. Thank you for watching. Have a good time. I will also try to create more about the more interesting things that I do. Yes, I think that's the future anyways.